Okay, here's an example video. We are going to resolve vectors m and b. All right, and so we have our boulder, which I'm going to put in black here. We have our boulder, and we have two vectors affecting it. We have boulder, or vector m, which is the force of the man. Okay, and we also have vector b, which is the gravitational force of the boulder. Okay, and we're ignoring, for the moment, we're ignoring the other forces in our free body diagram that affect this boulder. And so we're going to go ahead and we're going to take a look at this set of vectors, and we're going to break them down. So first, as you know, we want to get into our components. Well, the red vector, the vector that for the boulder, is just 750 pounds, and it's only in the y direction, so we don't have to find any components of that. However, the blue vector is at a 25-degree angle with the horizontal, and so we're going to need to resolve that. So this is a 25-degree angle here, and we know that the magnitude of the vector is 225 pounds, and so we want to find what the x and y components of the m vector are, not the b vector, of course, of what the m vector are. And so let's go ahead and find those. And so mx and my, and of course this 750 is just going to be the y value. So we're going to resolve all of our x components first. So let's look at all of our x components. And so our x vector components, we have mx, which is going to equal 225 times the cosine of 25 degrees, and it's going left, so it's also going to be negative. And the y, or the x component of the boulder, is 0, because there is no x component. So the result of the x is, and this negative 225, if we can go ahead and get that on its own here, this negative 225, the value for that is times cosine of 25 is going to give us a value of negative 203.92. And so the resultant x is negative 203.92. And then now let's go ahead and do our y values. So our y components, we have my, which is going to be 225 times the sine of 25. And that is going to get us 95.09. And that's going up. Of course, this is negative, which tells us it's going left. And then by, the boulder, is of course just 750, and that's going down. And so the resultant, if we add those together, the resultant y value is going to be negative 654.91. And that's, of course, means it's going down. So there's our information that we need. We have our x component and our y component, right? And our x component is going to the left, our y component is going down, and so we go ahead and draw that, and the x component is about 1/3 of the y component. So let's go ahead and draw our resultant vector. So the result of this, if we didn't have a ground to push back, would be going to the left, and this is 203.92, and then going down about 3 times as far, and this is 654.91. And then that means our result, which I'm going to draw a little bit bigger because it is bigger, our resultant vector then is here, and this is our result vector. Okay. And so let's go ahead and do the calculations for that vector. Let's find out, what size and what amount is that vector. So if we want the magnitude of that vector, one thing that we'll do is we'll just do Pythagorean theorem. So we're going to do r squared equals 203.92 squared plus 654.91 squared. And so that's going to get us r equals, if we end up doing that math, it's not too difficult to get, we get 685.92. And so that is the magnitude of the resultant vector. And now put that unit on there, pounds. The sense, of course, is going to be left and down. And then the direction, this is an angle. Okay, this is an angle. And so we need to find this angle right here, this theta. And so theta is going to be the inverse tangent of the y over the x. And so it's going to be the theta equals the inverse tangent, in this case, of 654.91 over 203.92. And in this case, that means theta equals 72.7 degrees. And so the direction is 72.7 degrees from the x-axis. All right? And so that's our solution. And you ask yourself, well, wait, Mr. Cooch, this boulder would not be going down. This boulder is not going to be going this direction. What is going on? And the reason it's not is because we also have these other forces that we've ignored for this problem. We ignored the normal force. And that normal force pushes back, right? That normal force is pushing back against that natural tendency of the boulder and keeping it from going through. And so that is a vector problem, getting the resultant vector from two vectors.